Okay, so topic 20, solving by factoring. So we're going to look at two concepts here, factor by grouping. So we talked about that a little bit in topic 19. And then we're going to talk about the zero product property. So the only thing about that zero product property is we're using those same skills of factoring, but we're setting our answers equal to 0 to find our final answers. So that's the only addition to that zero product property. So the first concept, factor by grouping. Remember when topic 19, when we did factor by grouping, I said if you see 4 terms, then you separate the first 2 terms in parentheses, then the second 2 terms in parentheses. For these problems, we're going to have to do one additional step before we get our 4 terms. So here are the steps for factoring. We have to first see if it has a GCF. So we look at all the numbers and see if we can take out any additional number. We multiply the A and C value. So in example 1, the A value would be 2. What would the C value be? 6. Then we find 2 numbers that multiply to A to C, but add to B. What's the B in example 1? 7. And then we rewrite the middle term, and that will give us those 4 terms to do factor by grouping. And then we continue to that part. Okay. It will make more sense when we look at the example. So starting with example 1, our first step is to see if we can take out a GCF. Is there a GCF we can take out between 2, 7, and 6? No, so we skip that step. Then we have to multiply A times C. So again, I'm going to label everything. This is A, B, and C. And off to the side, I'm going to say A times C is equal to 2 times 6, which is 12. And our B value is 7. Okay, so I took my A and my C value, multiplied them, and then my B value is 7. So now I need 2 numbers that multiply to 12, but add to 7. What would those 2 numbers be?
3 times 4.
3 times 4. 3 times 4 multiplies to 12 and also adds to 7. So that means instead of writing our B value of 7x, we are going to split the 7x into 3x plus 4x. So we have 2x squared plus 3x plus 4x plus 6. Again, the only thing we did here is we took our 7x and we split it up into 3x and 4x. So technically these 2 equations are the same, correct? They're exactly the same. Now that we have 4 terms, we're going to do our factor by grouping. So this goes back to the skill that we learned in topic 19. So factor by grouping, remember we group the first 2 together and then the last 2. And then what do we do from each parenthesis? You guys remember? Good, factor by taking out a
GCF?
Yes, a GCF. So looking at the first parentheses, what's the GCF between 2x squared and 3x?
X.
Just x. So I'm going to take out an x. So if I take out an x, I'm now dividing. So what's 2x squared divided by x? 2x, right? Because only one of the x's came out and nothing happened to the 2. What about 3x divided by x? 3. Okay, so that's the first parenthesis. What's the GCF we can take out of the second one?
2.
A 2. And we'd be left with what once we divide? 2x plus 3. Who remembers what I said last week about these 2 parentheses? They have to be the same. So if they're the same, that means we did everything correctly. Okay? So now we have our factors of 2x plus 3 because we rewrite one of those parentheses. And what would be our other factor?
X plus 2.
X plus 2, whatever is on the outside. And this is our answer. This is our answer because it's asking us just to factor, not to solve. Okay, we're just factoring here. Any questions on the steps? Yes.
Why do that at the end? You said, what did you say again? So like for your final answer?
Okay, so your final answer, you rewrite one of these parentheses because they're the same. So we rewrote that 2x plus 3. And then whatever's left on the outside is your second parentheses. So x and 2 gave us x plus 2. Okay. Any other questions? Okay. So let's go ahead and do the same thing for number 2. Number 2, remember our first step is to see if we can take out a GCF. Does this one have a GCF we can take out? No, so we continue to the next step. I'm going to label everything. So this is A, B, and C. And then we have to do our A times C, which is going to be what two numbers? Yep, 2 times 3, which is 6. And then we write our B value, which is 5. Remember that B value is always the middle term. So from here, this tells us we need two numbers that multiply to 6, but add to 5.
It's 2 times
2
3.
times 3. Because 2 times 3 is 6, and 2 plus 3 is 5. What am I going to do with that 2 and 3? Good, I'm going to expand my B value. So instead of 5x, I'm going to write what?
2x squared plus 2x plus 3x plus 3.
Correct. So 2x squared plus 2x plus 3x plus 3. I always take that b term and expand it into two b terms. I do this because I want to do factor by grouping. So remember, factor by grouping, I pair the first two and then the last two. And then looking at the first two, what's the GCF I can take out? 2x, and I'd be left with what after I divide? X plus 1. Good. What can I take out of the second one? 3, and I'd be left with what? X plus 1. Is my parentheses the same? Yes, that means my answer is x plus 1, and what else? Good, 2x plus 3, whatever is on the outside. So we are taking these quadratic equations up at the top. We are factoring them into two pairs because these factors, when we solve in the next concept, are going to give us the roots, the x-intercepts. So that's why we're learning this skill. So quadratic equation, we're finding the x-intercepts. Okay, any questions on 2? Okay, number 3. Before we start, what's wrong with this problem? Good, it's not in the correct order. So what should come first? That x squared. So 8x squared, and then what should come next? That negative 2x, and then that negative 3. We have to make sure that it's in standard form first, which is that ax squared plus bx plus c. Remember, our x squared has to come first, then our x, and then our constant. Can we take out a GCF? No? So then our next step is to do what? A times c. And what is a and c? 8 and what? negative 3. We always include those signs. So 8 times negative 3 is negative 24. And what's our b value? Negative 2. Okay, so now we need two numbers that multiply to negative 24, but add to negative 2. Any ideas? 4 and 6, but which one's going to be negative? The 6. So negative 6 times 4 gives us negative 24, and negative 6 plus 4 gives us negative 2. So that means instead of writing that negative 2x for our b value, we're going to be writing what? Negative 6x and 4x. So 8x squared minus 6x plus 4x minus 3. So we expanded our b value, so we have 4 terms. Now we do what? Factor by grouping. What's our next step? The GCF. So what's the GCF of the first one? 2x, good. And we're left with what? When we divide. 4x minus 3. Can we take a GCF out of the second one? No, and if we can't take it out, then we assume it's what number? 1. Because remember, we can take out a 1, and it's not going to change our problem. So it's still going to be 4x minus 3, because if we divide everything by 1, we're going to get that same answer. Do we have matching parentheses? Okay, so that means our answer is 4x minus 3 and 2x plus 1. Remember, if we take out a positive number, it's plus. If we take out a negative number, then it's going to be minus. Okay. So the only difference here in 3 is we had to put it in standard form first. Any questions?
So in this case, even though we divided by 1 across the, from the 4x minus 3, it's still going to be 2x plus 1 versus 2x minus 1?
Correct. Because we just took out a positive 1. If we took out a negative 1, then it'd be 2x minus 1. Okay. Let's look at... Let's look at number 5. Okay, so now we have an extra x in there. So we have x cubed, x squared, x. Is this in standard form? Are the x's decreasing?
Yes.
Yes, so it's in standard form. The x's are decreasing. Can we take a GCF out of this problem? Yes, what would be the GCF?
5x.
Make sure that's the one. Correct, 5x. So we can take out a GCF of 5x, which means before we start this problem, we're going to have to divide every term by 5x. So 5x remains on the outside. Draw our parentheses. So what's 10x cubed divided by 5x?
2x squared.
2x squared. Okay. What about negative 85x squared divided by 5x? Negative 17x. And then lastly, 105x divided by 5x. 21. Okay. Now look inside the parentheses. Does this look like a quadratic equation?
Yes.
Yep, and it is in standard form. So for now, we're going to ignore the GCF. We'll come back to it later, but we're just focusing on what is inside the parentheses. So if I label my A, B, and C, my first step is to do what?
A times C.
A times C. So A times C is going to be 2 times 21, which gives us 42. And then our B value is what number? Negative 17. So we need two numbers that multiply to 42, but add to negative 17. Okay. And this could be one of those cases where we can't think of it at the top of our head, so we could just start writing all the multiples of 42. So we know 1 times 42 gives us 42. What else? 2 times 21. Does 3 go into 42? 3 and 14. And then lastly, it's 6 and 7. So out of any of these, could we manipulate these numbers to give us negative 17 when we add?
3 times 14.
3 times 14. Would the 3 and 14 remain positive, or would we have to change them?
They both be negative.
They would both be negative. Okay, so that means this is the pair we're using, negative 3 and negative 14, because they multiply to a positive 42, but add to a negative 17. So none of these ones. Okay. That's the method you would go through if you can't think of the factors at the top of your head. Write all the multiples for our A times C. Okay, so now rewriting our problem, we have 2x squared minus 3x minus 14x plus 21. I expanded my B term, wrote my two multiples in there. Now I do factor by grouping. And what's the GCF I can take out of the first one?
X.
Just an x, yep. And I'd be left with what? 2x minus 3. What can I take out of that second parenthesis so my parentheses match? A negative 7, because I want a positive 2x. So if I take out a negative 7, I'm left with positive 2x and then that negative 3. So I always want my parentheses to match. So if you would have took out a positive 7, the signs here would be off, and that would tell you you did something wrong. So that means I have my answer 2x minus 3 and x minus 7. Correct. That would be our last step, is if we take out a GCF, whatever that GCF from the beginning has to come down into our answer. So this 5x would have to be included.
So that's the final answer.
The final answer is if we have a GCF and then our two factors. Before, we never had a GCF, so we never had to bring anything down. But if we don't have a GCF, we always assume the GCF is what number? 1. And we don't write a 1 in front because that does nothing for our problem. So technically, we are having the GCF in the answer every time, but we don't need to write 1 times something because it doesn't change the problem. Okay. Any questions on 5? Okay. Let's look at number 6. Okay. Number 6 is similar to number 5. Because we have these additional y's in here, right away this tells you that we can take out a GCF. What's the GCF we can take out of number 6? 3y. Good. So GCF, 3y. So I'm going to write 3y on the outside, draw my parentheses, and start dividing. So what's 9y cubed divided by 3y? 3y squared, good. What about negative 30y squared divided by 3y?
Minus
Minus
10.
10y. And then lastly, 24y divided by 3y. 8. Remember, inside this parenthesis, once we take out the GCF, we want that parenthesis to look like the standard form for a quadratic equation. So y squared, y, and a constant. Next step.
A times C.
A times C, our A times C is 3 times 8, so 24. And what's our B value? Negative 10. Remember, the B value is the number in the middle. So what would be 2 factors of 24 that would add to negative 10? Correct. Minus 4 and minus 6. So a negative 4 and a negative 6, when we add them, gives us a negative 10, but when we multiply them, gives us a positive 24. So I have 3y squared minus 4y minus 6y plus 8. So I expanded my b value into 2 terms. What's my GCF that I can take out of the first one? Yep, just y. And we'd be left with what? 3y minus 4, because we're only taking out one of those y's, and that 3y squared still has a y. Okay, what can we take out of the second parenthesis in order for our 2 parentheses to match? Negative 2. And we'd be left with what? So that means my answer is 3y minus 4 and y minus 2. And what do I need to bring down? That 3y, because it was my GCF. So this is my answer. Okay. Let's look at number 8. Any questions on 6 before we move on to 8? What do we notice about 8? We have an extra variable, so we have x's and y's. Okay. When we have 2 variables, okay, we're going to look at each term and see, how can I phrase this? If we see 2 variables, we're going to always keep x there, and we're going to ignore the y's. So in the beginning, I'm going to ignore this y and ignore that y. They're going to come back in our answer, but for now we're ignoring them. So that means I have negative 8x squared minus 8x plus 30. Okay. So we're ignoring the y's, we're going to come back. Now looking at our problem, it looks like it's a standard form quadratic equation. Can we take out a GCF? What's the GCF? Okay, the GCF is 2, but I don't really like the negative to be in that a value. So what could we take out instead? Instead of a 2, we could take out a negative 2. So GCF negative 2. And the reason we're taking out a negative 2 is because it's a lot easier to get rid of that negative in the a value. Bless you. So if we take out a negative 2, what are we left with? 4x squared plus 4x minus what? 15. In this case, our GCF was just a number. It's not a number and a variable, so only the numbers changed in the problem.
Question, how come it's not negative? Oh, because the third one doesn't have something, the x in common, sorry.
Correct. Okay.
And that's why it was a negative 2x, but yeah.
Okay, so now looking at the parentheses, we have our A, B, and C value. So A times C is going to be 4 times negative 15, which is negative 60. And our B value is 4. So we need two numbers that multiply to negative 60 but add to 4. 10 and what? Correct. 10 times negative 6 gives us negative 60. And when we add 10 and negative 6, we get a positive 4. So good. We're going to use those two numbers. So I have 4x squared plus 10x minus 6x minus 15. I expanded my B value. What's my next step? So factor by grouping, and then I find my GCF. So what's the GCF of the first one? 2x, good. So 2x, and I'm left with 2x plus 5. And what would I have to take out from the second one in order for them to match? Negative 3, and then I have the matching 2x plus 5. Typically, when you have a negative right here in front of your second parenthesis set, usually you are taking out a negative for it to match.
Oh,
Okay. So that means I have the answers so far as 2x plus 5 and what? 2x minus 3. I'm leaving gaps at the end of that 5 and 3 because what variable did I tell you to ignore in the beginning? A y. So next to that 5 and negative 3, I'm going to put a y. That's where the y's come back in. Okay.
You can't put them next to x, like 2x, y.
No, it would have to be a part of the last number. Okay. And that will always be true. It's always where you're going to put that extra variable if it's there. And then what else are we missing from the front of our answer? The negative 2, because that was our GCF. So that this is our entire answer here.
And it's that simple with the y's?
Yes. Every time it will work. So if whatever this extra variable is, so let's say the variables were a and b, and you saw a squared, ab, b squared, you'd always cancel out what that second variable is.
Okay.
And then you would put them down here. Okay. Let's look at number 9. And what do you notice about number 9?
There's no GCF?
There's no GCF. And are we able to have we learned a way to factor if we see x to the 4th, x squared, and then nothing?
Can't we just use x?
So we couldn't just use x and do everything we were doing before because we would end up with x squared as our answer, and we want x to the 4th. So if you see stuff like this, where it's like x to the 4th and then x squared, okay? Notice that x squared, so this is my little note. Notice that x squared, if we squared that, would become what? X to the 4th. So if we see our b value and we're able to square that and it gives us our a value, we will be using u substitution. And what u substitution is we are going to assign u. So we assign u a value so the problem looks like au squared plus bu plus c. Your u value is always the variable next to b. So for this example, what is our u going to be equal to? Always the variable next to b. So x squared. Okay? It's always this part next to the b. So if we're looking at this new standard form of au squared plus bu plus c, we now have our u value, and we need to find our u squared value. And all we do to find u squared is to take our u value, which is x squared, square it, and that gives us x to the fourth. That's what we explained up here. So that means in our problem, instead of writing x to the fourth, I'm going to write 2u squared. And instead of writing x squared, I'm going to write u. And then now I have my problem in a quadratic equation that can be factored.
I'm confused.
Yes.
So could you just say, like, if you know you don't have the GCF, and you could just say, like, and it's in the same order, like the 4 and the 2, you could just throw everything over, like, 2, do you have to show you that it's u substitution, or can we just be like 2,
If you
2x squared?
if you go from this step to this step, that's fine. I'm just showing all this for the notes. Okay. So this could be true if, okay, so notice that x to the fourth and x squared, if I square x squared, I get x to the fourth. That means I could have these numbers as 6 and 3, right? Because if you square x cubed, you get x to the, remember we talked about those exponent properties?
Repeat your question.
Let me rewrite this. Properties of exponents. If we have an exponent being raised to another exponent, we multiply. So this is x2 times 6, which is x to the 12th. So if we have an exponent raised to an exponent, we multiply them. So what I'm trying to say here is that this is not the only time you would use u substitution. You wouldn't only use it if you see x to the fourth and x squared. You could use it if you see x to the 6 and x cubed.
At that point, can we just put 2u squared plus 5u again?
Mm-hmm. So if pretty much if you're if the number is doubled, right? Because it was 4 and 2 doubled is 4.
Okay.
6 and 3 doubled is 6. So then this could be 12 and 6 doubled is 12. All of these choices still leads you to this. There'll be one question like this on the test. Just heads up. Okay. So once we get everything in our terms of u, we're still doing all the same steps. Okay. So we have our a, b, and c value. So we still do a times c, which is 2 times 2, gives us 4. And what's our b value? 5. So what's two numbers that multiply to 4 but add to 5? 1 times 4. So that means we have 2u squared plus u, because I don't need to write 1u, okay, plus 4u plus 2. Still do our factor by grouping. And what would we take out of the first parenthesis?
U.
U, good. So then it would be 2u plus 1. And what about the second parenthesis? 2. So we would get 2u plus 1. So that means we have an answer of 2u plus 1 and u plus 2. Okay. However, our original problem was not in terms of u. It was in terms of what?
X.
X. And what did we say in the beginning that u is equal to?
X squared.
So instead of writing the u's, we're going to write x squared. So this is 2x squared plus 1 and x squared plus 2. This is our answer because we have to plug our values for u back in to get our answer. Okay, so this is all the work on this side. The right side was just the notes. So again, on the test, you could jump from here to here, and then I would see this work. Yes?
You said it's x squared, but what if it was like to the third? Would it be like x cubed then? That's your final answer?
Yes, whatever you assign your u value.
But it's always going to be the b value?
Always the b value. Correct. So if your variable next to b was x cubed, your answers would have x cubed. If your variable next to b was m to the 12th, then you would plug m to the 12th back in.
It's not too bad.
Okay, last one for this concept, we're going to look at number 13. Okay, for number 13 is this in standard form.
Yes.
Can we take out a GCF?
No.
So what's our first step? Multiply A and C. So we have A, B, and C. Multiplying A times C, we get what times what?
1 times 24.
1 times 24, which is 24. And what's our B value? -4. So we need to find two numbers that multiply to 24, but add to -4. So -8 times 3 would give us a -24. So they would have to both be negative in this case. So that wouldn't work. Any other ideas? Let's go ahead and just list the factors of 24. So the factors of 24 is 1 times 24, then what?
2 times 12.
2 times 12. Anything else?
3 times 4.
3 times 8.
Oh, 8, sorry.
And then there's one more factor.
4 times 6.
4 times 6. And of course, all these factors could be manipulated with negatives, positives, so on and so forth. So looking at all these choices, would any of these combinations give us a -4? No. So what does that mean for this problem? Not no solution, because the question is to factor this. So not no solution, but not factorable. So this is not factorable. If this was asking us to solve, since this cannot be factored, remember we can always solve a quadratic equation using what formula? No.
What was your question?
So if this is not factorable, which is okay because this question is asking us to factor. If the question was asking us to solve, how do we always solve a quadratic equation and it works every time? Quadratic formula. So if asked to solve, use the quadratic formula to get the answer. Now remember, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So for this question, the answer is not factorable. But if you're asked to solve, you use the quadratic formula. The reason we choose to factor first is because factoring takes less time than using the quadratic formula. That's why we always check to see if it can factor first. Okay? But the quadratic formula works every single time. There's not one instance where it does not work. Okay? Okay, so go ahead and go down to the next concept, which is the zero product property. Before I talk about that zero product property, I want you to let you know that all these questions right here are exactly the same as the questions above. Okay? In this part, the only difference we're doing is after we factor, we find the answer, we solve. So the zero product property says if we have two factors, okay, so in this case that ax plus d and bx plus c, we can set these two factors equal to 0 and solve for x. Okay. So in these examples, it says we already factored these problems above, so we're going to use the zero product property to find the solutions. Okay. And I'm going to do the same correlating problems. So I know we did this first one. Okay. I'm going to go ahead and just write the answer that we got, okay? The answer that we got for this one was that x plus 2, 2x plus 3. Again, these problems are the exact same problems from the previous concept. So we don't have to refactor them. We already did the work.
I have something else. Oh, you wrote it backwards. Sorry.
Oh yeah, if it's written in the opposite order, it's fine. Because when we multiply something, 2 times 3 is the same as 3 times 2.
Yeah.
Okay. Once we have our factors, we're going to set this equal to 0. This part where we just set this equal to 0, this is using the zero product property. And what that tells us is that if this whole thing is equal to 0, that means each part is also equal to 0. So we would write x plus 2 equals 0 and 2x plus 3 equals 0. All I did is take each parenthesis and set it equal to 0. The reason I do that is because I want to solve for x. So in the first one, x plus 2 equals 0, what would we have to do to get x by itself? Subtract 2. So we have x is equal to negative 2. That's our first answer. What would we have to do first for the second one?
Subtract 3.
Subtract 3, and we get 2x is equal to negative 3. What's next?
Divide by 2.
Divide by 2, and we get x is equal to negative 3/2. That's our second answer. And that's it. That's that last additional step.
That's it?
So once you find the factors, if it's asking you to solve, then you just set them equal to 0. These solutions, this x equals negative 2 and x equals negative 3/2, are our x-intercepts. So if we were to look at a graph, these would be our x-intercepts. Remember, another name for x-intercepts are zeros and roots. These are all the same thing. They're all the same thing, just different ways to word them. So in a problem, instead of saying solve, they could say find the x-intercepts. Okay, and you would do these same steps. Or they could say find the roots. You would do the same steps. Okay. What was the next one? We did the one next to it, right? That 2x? Okay. So again, we already did the work for this problem, and we got 2x plus 3 and x plus 1. So we already did the work. We already factored. So what is our first step here?
Equals 0.
Equals 0, and that tells us to do what?
Set them all to equal 0.
Yep, each one equal to 0. So what do I have to do to that first one to get 0? Or sorry, to get x by itself? Minus 3, and I get 2x is equal to negative 3. Then divide by 2, I get x is equal to negative 3/2. First answer. What would be my second answer?
Negative 1.
Negative 1, because I just subtract 1. And that's it. Okay. And then we did this one next, right? That negative 2x plus 8x squared. Correct? Okay. Okay, so when we did that, we got these as our factors. We got 2x plus 1 and 4x minus 1. I'm only doing the problems that we've already factored.
Professor, is it 4x minus 3 or 4x minus 1? Did you all get that?
Is that what we got last time, the 4x
Yeah,
minus?
-3.
Okay. And I just rewrote it. Okay. So we're going to set this equal to 0, and that tells us what?
Oh, I've set everything to equal 0.
Correct. So 2x plus 1 equals 0. 4x minus 3 equals 0. Okay, go ahead and solve for x for each one. Okay, and you should have got negative 1/2 and 3/4. Okay. What was the next problem that we did? What did it start with? Okay, so it's this one, 10x cubed. So for this one, we got our factors to be 5x times 2x minus 3, x minus 7. Look good? Make sure it matches. And remember, it doesn't matter the order of the parentheses as long as they're both there. Okay, so when we factor this, we got this. we're going to set everything equal to 0, but since we have a GCF in the front, we have to also set that part equal to 0. Okay? So I have 5x equals 0, 2x minus 3 equals 0, x minus 7 equals 0. So what does that tell us about the problem? Instead of 2 x-intercepts, we're going to have
3.
potentially 3. Okay? So for the first one, to get x by itself, what are we doing?
Divide by 5.
Divide by 5, and that tells us that x is equal to 0. Okay? Then do the same thing for the other two. Solve them for x. Okay. So you should have got 0, 3 halves, and 7. Okay. And did we do this one next, that 9y cubed? Okay. So for this one, we got the factors of 3y minus 4, and y minus 2. So again, this tells us we're having how many terms equal to 0?
3.
3. So go ahead and set them all equal to 0 and solve. Means we're having 3 answers here. Oops, I didn't need that 0.
So is the GCF always going to equal 0?
No. The only reason it equals 0 now is because it has a variable. What if our GCF was just a number? What if it was just a 2? 2 equals 0. Does that make sense? That's a false statement, so that means we would just have our 2 answers instead of our 3. Okay, so only if it has a variable, then yes, it would be equal to 0. So in this case, we got the answers 0, 4/3, and 2.
So that, well, no, that y equals 0 would mean that it does cross, right?
Yes, it crosses at 0.
Okay.
Okay.
Is it still x-intercept and y?
Yes, they technically yes, they just switched the variable on us. If we were looking at a graph, they would be in terms of x. So just keep in mind, these are still x-intercepts. They just changed the variable on us. Okay. I know the next one we did involved y's and x's. You'll never get a problem like that that says solve, because you would have to know what either x is or y is to solve for the other variable.
That's number, which one was that, 27 or 28?
Whichever one has that negative 8x squared minus 8x y, yeah. So if it has 2 variables in it, you're never going to be asked to solve it, okay? Just factor it. So we're not going to do that one. The next one, okay, and then the next one we did was the one that wasn't factorable, right?
Number 9 is the 2x, no, the 2x4? Or
Oh, correct. Again, you would not be asked to solve those type of problems. The only ones you'd be asked to solve are the ones where if we take out a GCF, you get a proper quadratic equation, or if you're already given a proper quadratic equation. And then, wasn't there one that we just took out a number? Let me look. Yep, you wouldn't do
Yeah,
those.
unfortunately, it would be minus x squared,
Okay.
8xy.
Yeah. Okay.
That non-factorable one, we're not gonna be asked to solve that either?
You would be using the quadratic equation. Okay. So what I'm going to go ahead and do now